Good afternoon. My name is Peter Hubacheck and I'm the project manager for RJK. My career spans over 43 years as a mineral exploration geologist. I gained earlier experience with Texas Gulf, Pan Ocean Oil, Agnico Eagle, working with many base metal and precious metal discovery teams, and more recently with Sage Gold and RJK Explorations. During the late 80s and 90s, I had the full support of Agnico Eagle, headed by my father and Paul Penna, to follow up on the Diamond Lake discovery in 1989. During the next 6 years, the Sudbury Contact Exploration Team, managed by our firm, discovered 5 kimberlites in the Nipissing structural zone with logistical support from the Agnico Eagle Silver Division. I have remained active in diamond exploration, participating with the OGS Operation Treasure Hunt in 2001, also in the Cobalt Camp as a director with Contact Diamond, and in 2008 performed till sampling in Lorraine and South Lorraine townships in 2012. Recently, I've joined RJK's exploration team to search for the source of the famous Nipissing Diamond. Slide number 1, the Cobalt area lies within the superior structural province of the Canadian Shield. Archean basement rocks consist of northwest to southeast trending Archean volcanics intruded by mafic, ultramafic, and granitic intrusives. The Archean rocks are unconformably overlain by relatively flat-lying Proterozoic sediments. The sediments consist of conglomerates, greywackies, and quartzites of the Coleman member. The Archean and Proterozoic rocks were intruded by the Nipissing Diabase Silla intrusive event. Nipissing Diabase was intruded approximately 2.2 billion years ago as sills, cones, and dikes. The diabase takes the shape of basins and domes where intruded as a sill sheet. There are 3 major northeast trending structures: the West Cobalt Lake Fault, the Kerr Arch, and Schumann Arch. There are 2 major northwest to southeast trending structures: the Cross Lake and Montreal River faults, shown in purple. In 2019, the Mineral Exploration Research Center has published the Cobalt Seismic Transect under the direction of Dr. Shauna White. The 40-kilometer transect was conducted on Highway 567 from the east side of Cobalt through Buck and Lorraine townships, terminating in South Lorraine. The seismic line is shown on the right-hand side of the slide here. The Bishop and Kon properties area exploration areas are shown in yellow. The next image shows a cobalt seismic cross-section, which has been reversed so that the viewer is looking east. The left side is north and the right side is south. You can see 5 truncated and layered metamorphic domains of the lithosphere mapped down to depths of 30 to 40 kilometers. Additional structural information has been added to the MERC interpretation, shown by the colored faults in blue, green, and red, based on geological mapping and regional airborne magnetic maps. Note the high-angle thrust faults in red, which we've called the Latour fault, and the Cross Lake fault, shown in green. These faults appear to flatten to the south at 30 kilometers to 40 kilometer depths, and perhaps originate in the lower lithosphere below the Grenville fault boundary. This fault in red here is the Latour structure, which shows this flattening trend. The next slide shows the location of the Grenville Geological Province, located between the Archean Superior Province and the Appalachian Front. In this paper by Hines and Rivers, the Grenville orogeny have northern margins characterized by long-lived subduction before continental collision and protracted convergence following collision, approximately 1 billion years ago. Section line MG depicts the interpreted profiles that may affect the subsurface region where the Kon and Paradis kimberlites are located. That's this line shown here. The next image shows the cross-section C, interpreted from lithoprobe seismic surveys carried out by the Geological Survey of Canada. Archean rocks of the Superior Province are interpreted to be present in the subsurface and extend more than 200 kilometers southeast of the Grenville Front in Western Quebec. A lithospheric root zone is evident in high seismic velocities at 200-kilometer depths into the diamond stability field of the lower crust. The white dashed line shows the position of the Latour Fault, which is an example of cratonward propagating thrusting facing to the northwest. This is a conjectural opinion as to the positioning of this fault, but it's fairly close to being true scale. The Cross Lake and Latour Lake faults may be important conduits for deep-seated kimberlite intrusions sourcing from this lithospheric root zone. The next slide shows the position of the Kon and Paradis occurrences. And they are located in the Proterozoic mobile belt, which is proximal to the Grenville Front boundary underlain by Archean crust. And the area, which is the area in the red ellipsoid shown on this map here. The blue colors represent high velocities implying low temperatures. The Victor pipe is more centrally located in the Superior Province craton, and that's shown here to the northwest of the Kon Paradis trend in the Nipissing structural zone. The next image depicts a structural cross-section transecting the Schumann Arch and Goodwin Lake Basin, crossing over RJK's land holdings. The Nipissing Diabase sill intrudes Lorraine granites with the Schumann Arch showing as an antiform, then gently folding into a synform towards the Goodwin Lake Basin. The Lightning Lake Fault crosscuts the crest of the fold structure on the arch, and the Cross Lake Fault appears to terminate the Diabase sill in Goodwin Lake. To the east of Goodwin Lake, a steeply dipping mafic dike intrusion has been identified by recent drone magnetic surveys. The Paradis Pond diatreme kimberlite sill is shown on the east side of the dike structure, draping over Lorraine granite basement rocks. The possibility for kimberlite pipe intrusions are also shown proximal to the Cross Lake Fault and Lightning Lake Faults. Slide number 7 shows the recent drilling locations west of Paradis Pond. The northwest to southeast trending mafic dike intrusion extending for at least 2 kilometers flanks the east side of the Cross Lake Fault. The dike trend also falls within the footprint of an airborne regional conductance anomaly shown in the shaded region. Further drill testing of the dike trend and other magnetic low features along the Cross Lake Fault are planned. And this, the purple line here shows a drilling fence of 5 holes and located along the axis of this conductance trend. This slide depicts the northwest to southeast drill fence on the east side of Goodwin Lake, showing 5 holes spaced over a distance of 700 meters. The cross-section shows thickening of the kimberlite sill body from true thicknesses varying from 9 meters to 20 meters, moving westward and towards the Cross Lake Fault structure. The next slide shows the Kon kimberlite structure, flanked on the west side of the Montreal River Fault and on the east side of the north-south trending Giroux Lake Faults, and to the south by the extension of the west to east trending Latour Fault trend, which has been extrapolated westward from the Cobalt seismic transect. The Latour Fault trend is shown here in the yellow dash line coming through here. And the main Kon kimberlite #1 pipe structure is outlined here by the drone mag. And the original discovery, a kimberlite dike discovery, is shown just to the northwest here. And in addition, there's 4 other regional targets that are on the west side of the Montreal River outlined on the in this adjoining property. This image here shows the drone magnetic response, and again highlighting the key major structures that affect the area. And in the middle of this magnetic target, we see this the Maglo feature in here. And again, with the spatially located with respect to the Giroux fault system flanking the east side, Montreal River fault system on the west side, and the Latour fault on the south side here. The next image shows the Kon #1 magnetic target with the 3 drill hole locations that have tested the kimberlite body so far. The kimberlite dimensions and geometry are based on the drone survey, indicate 200 by 200 meter in size, east to west 250 meters, and north to south about 200 meters. On the west side of the structure, in hole number 8, there is ilmenite and chromite rich phases, which are in greater concentrations as opposed to the central part of the pipe. And the further infill drilling is needed to define these boundaries. And there is a suggested feeder vent possibly located on the northwest side of this structure based on the ilmenite and chromite rich phases found in hole number 8. The next slide shows the drill fence cross section from the northwest side of the Kon kimberlite structure towards the center of the structure. This is hole number 8 where the bulk sample was taken, and that returned 7 microdiamonds. Our understanding of the stratigraphy within the structure appears to be a layered stratigraphy with possibly 6 major phases, including 2 hypabyssal sill type structures shown in dark green here, and separated by 3 diatreme phases. There's based on this limited information, they appear to correlate over a distance of around 80 meters. Further drilling is planned to add to these drill fences and to define these phases in more detail. Well, in closing, it's a rare opportunity to be able to explore a major mining camp for the second time in over 100 years using advanced exploration methods. The Cobalt Mining Camp was the richest camp in comparison with other historic camps in its day, such as Barkerville, the Klondike, and Larder Lake gold rushes. And I'm pleased to join the RJK team, including the Kazar, McKay, and Chitteroni families. All of our family roots are connected to cobalt, and we have come together to discover the true mineral endowment of the Cobalt Camp. Stay tuned.